The operation symbol is defined as a symbol b is a times 2b plus 4 for integers a and b. For example, 3 symbol 6 is 2 times 6 plus 4, which is 48. What is the value of 5 symbol 1? So according to this definition, it would be 5 times 2 times 1 plus 4, and that is 30. If k symbol 2 is 24, what is k? So again, according to the definition, it would be k times 2 plus 4 is 24. And that would be 8k is 24. And solving that, you get k equal to 3. Determine all values of p for which p symbol 3 is equal to 3 symbol p. All right. So that guy would be p times 2 times 3 plus 4. And that next part would be 3 times 2 times p plus 4. So this looks like 10p, and this looks like 6p plus 12. So that would be 4p is 12, and therefore p is equal to 3. And finally, determine all values of m for which m symbol m plus 1 is equal to 0. All right. So let's do that. We've got m times 2 times m plus 1 plus 4, and that is equal to 0. So this looks to me like m times 2m plus 2 plus 4 is equal to 0. So that's going to be m times 2m plus 6, I believe. Okay, so I don't need to expand. I can just figure this out from the brackets that m is either 0 as m or m is equal to minus 3. And that is the completion of number 1. The organizer for a sports league with 4 teams has entered some of the end of season data into the table shown. Each team played 27 games, and each game resulted in a win for one team and a loss for the other team, or in a tie for both teams. Each team earned 2 points for a win, 0 for a loss, and 1 point for a tie. How many ties did Team P have at the end of the season? Okay, so we got 23 points, right? Great. 27 games. Well, they've already told you the number of wins and losses, which is 14. So, sorry, 10 plus 14, which is 24. So I guess you just do 27 minus 24 to get the number of ties, which is 3. Okay, so next one. Team Q had 2 more wins than Team P and 4 fewer losses. How many total points did Team Q have at the end of the season? Okay, so Team Q had 2 more wins than P, so this becomes a 12. And 4 fewer losses, so this becomes a 10. Correct? And then the number of ties would be 27 minus 22, right? That plus that is 22. So 27 minus 22 is 5. So the number of points, you get 2 points for a win, and then you get 1 point for a tie. So that's going to be 24 plus 5, which is 29. So 29 points is the answer. Explain why Team R could not have finished the season with exactly 6 ties. Okay. Well, Team R, they tell you the number of points is 25, right? Let's say it had 6 ties. If it had 6 ties, that means 25 minus 6, which is 19, would have to come from the wins. So let's say the number of wins was W. So that would mean that 2W is equal to 19, correct? Because you get 2 points for every win. But that would mean that W is equal to 9.5, and that is not possible because the number of wins has to be an integer, right? And part D, at the end of the season, Team 4 had 4 more wins than losses, so that Team S must have finished the season with a total of 31 points. All right. So the number of losses I'll just call L, and the number of wins they're saying is 4 more than that, so it's L plus 4. Okay. And then this guy here, the number of ties, that's going to be 27 minus L minus 4 minus L. You just have to subtract these two guys, right? So that's going to be 23 minus 2L, correct? So 23 minus 2L goes there. So the number of points, okay, well, the number of points is the number of wins times 2 plus the number of ties times 1. So that's going to be 2L plus 8 plus 23 minus 2L. Oh, the 2L's cancel, and that's how you get 31. There you go. Rectangle ABCD has vertices 8, 0, 0, 0, 12, 6, 12, and 6, 0. Diagonals AC and BD intersect at E. What is the area of ADE? All right. So let's draw a diagram, and let's label this. Let's see if I can draw this nice. And we're going to have the diagonals like that. Okay, so what are we asking? Oh, the area of ADE. So this is A, and then this is D, and I believe this is B, and this is C, right? And then obviously that's E, the intersection point. Okay, so ADE, if we knew the height, I can figure this out. Triangle ADE, the area would be 1/2 base times height. The base is from here to here, which the coordinates of D are what? 6, 0, right? So that means that the base is 6. And then the height, that I don't know. I would need to know the coordinates of E. Okay, so what's a quick way of doing this here? I guess we just have to kind of we'll do it the long way, I guess, or if I don't even know if there's a shortcut. Okay, fine. Let's do the equation of AC. So that's going to be y is equal to mx plus b, right? And because it goes through the origin, b is 0. And then that means y is equal to mx. And then c has coordinates 6, 12, right? So if you plug that in, that means 6m is 12, so that m is 2. So that equation is y is equal to 2x. And then we're going to find the equation BD. Same story. Y is equal to mx plus b. And when what am I going to do here? I'm going to substitute a point, right? So which point am I going to use? What's b again? B was 0, 12. So 0, 12 like that. So, or I can just do the slope formula. That 12 minus 0 over 0 minus 6 is m, like that, plus b. And then substitute in any point, so I'll just substitute in b. So when x is 0, y is 12. So that means b is 12. And then going back, therefore it's going to be y is equal to, what is that, minus 2? Minus 2x plus 12. Okay, so you guys know how to figure out the equations of lines. I mean, it's kind of painful to have to do it again. So then to find the coordinate E, you just set them equal to each other. And that means 12 is equal to 4x, so x is equal to 3. So the coordinates for E are 3, and then we need the y, right? So substitute it back into any of these guys, and when you do, you get 6. So 3, 6 is the coordinates for E. So then finally, we can figure out the height. The height is just the y coordinate. So that's this guy. So then that's placed there, and therefore that makes this 18. So big long song and dance to figure out something as simple as that. Okay, point B. P, 0P lies on the segment AP. The area of the trapezoid BCDP is twice that of PAD. What is the value of P? All right. Let's make a diagram again. So let's see here. We've got, I think it's the same stuff, right? So the same coordinates, but this time we just got this P here, and I have no idea where the P is. I guess we have to sort of just guess. So I'll just say it's here. I'm going to say that's P. And then they're saying that when you draw BCDP, so BCDP. Okay. So this guy right here, that is being compared. And it's a ratio of 2 to 1, twice. Okay, I got it. Okay, so D was what? This was 6, right? 6, 0. And C was 6, 12. So the dimensions are 6 and 12. So 6 and 12 are the dimensions, and then the area of P would basically be, or sorry, the area of this triangle. I'm just going to call this whatever you want to call it. I guess trapezoid, TR, and triangle TI, whatever. So TR is equal to 2TI according to the question, correct? It's twice the area of PAD, right? Because this is A. All right, so we can work with this. Okay, so the area of the triangle is 1/2 base times height, so the base is 6 and the height is P. And the area of the trapezoid would just be 72 minus that, right? 72 because it's 6 times 12. Well, is 6 times 12? What is 6 times 12? Yeah, 72, if my math is correct. So 72 minus TI. Okay, so this was 2 times 3P. So this would be 72 minus 3P. So this would be 72 minus 3P is 6P. And therefore 72 is equal to 9P. And therefore P is equal to 8. And that solves that. The line passing through UVW divides ABCD into two trapezoids. Determine all possible values of U and W for which the ratio of these two trapezoids is 5 to 3. So let's make a diagram and let's see. So the first type of cut is something like that. So this is U and this is, well, this isn't going to be drawn to scale, but you guys get the point, and that point is going to be W. And then these two trapezoids, or whatever they're called, have the area ratio 5 to 3. So I'll just call them TA and TB. I'll call that one TA, and I call this one TP, trapezoid A, trapezoid B. So trapezoid A over trapezoid B, that ratio is 5 to 3, correct? Yeah. Okay, well, the total is, this is a 6 by 12 rectangle. So 6 times 12 is 72. So if it's 5 to 3, then that means that would be 45 and 27 would be how it would be broken up, right? The ratio 5 to 3. So let's just say it's 45 over 27 for TA over TB, because I don't know which one's bigger, right? Because we're not really sure how this line is. So let's just go with this first. Yeah. And then, or TB over TA is 45 over 27. Okay. All right. So let's go with that. Okay. Now, where do I go from here? Well, the first thing I'm going to do is I'm going to label this. This was 6W, I believe. V was what, 2,4? Yeah, V is 2,4. So 2,4. And U is 0 and U. Okay. I'm going to work with slopes. So 4 minus 0 over 2 minus U. 2 minus, hold on. I think it should have been 4 minus U. Yeah, 4 minus U over 2 minus 0 is equal to W minus 4 over 6 minus 2. Yeah. So the slope of UV and VW is the same. So this gives me 4 minus U times 4 is equal to 2 times W minus 4. So 16 minus 4U is equal to 2W minus 8. And therefore, 24 minus 2W is equal to 4U. Or 24 minus 4U is equal to 2W, whatever way you want to do this, and then W would be 12 minus 2U. Okay, all right. So we're going to use that a little bit later. That's going to come in handy. Okay, so now I've got to figure out this guy here. I'm working with this one. So TA is 45, so okay, how do I do this? Let me draw this imaginary line here, and then let's see, this dimension is 6. This guy from there to there would be 12 minus W, I believe. And then this triangle, I can do that easily. So TA would be first 6 times 12 minus W. Yeah, 6 times 12. And then 1/2 base times height for the triangle. The base is 6 and the height is W minus U, I believe. W minus U, yeah. And then we are setting that to be 45 according to this guy right here. So this is going to be 72 minus 6W plus 3W minus 3U, I believe, if that's correct. So let's put everything on one side. So this is going to be 27 is equal to 3W plus 3U. Okay, so that means W plus U is equal to 9. All right, that's working out pretty decent. And then that's when we substitute that in, and that will help us solve for one of these guys. So we got 12 minus 2U plus U is 9. So 3 would be equal to minus U is 0, so U is equal to 3. So my point U is 0, 3. And then if I put U equals 3 into here, I'm going to get 12 minus 6, so W is 6. So that means W, the coordinate is 6, 6. Okay, I believe that solves the question, but this question is a bit tricky because this is correct. This is the correct answer, that the 0, 3 and 6, 6, right? This guy right here that we just did. That is correct. But it's not the only answer. There's one other solution, and that's tricky, I think. And the reason is because the way that line, there's another way of drawing that line. It's like this. You see? Like that. If you draw the line like that, then you get a different coordinate for U and for W. So I'll do that. And let's see what happens. So we got the same kind of initial shape, but then now the line is going to be, something like this, like that. So if you were to extend this line here, as you can see, it's going to be a little bit different. The U is going to be down here this time. That's going to be my U. And then this guy up here is going to be W. You see what I mean? And then this is TA and TB in that whole big long song and dance. This is your TA and this is your TB. Now I'm kind of tempted to say, oh, you guys do this. It's very similar, but I'll just do it because it might be a little bit complicated. Okay. First, let's label this. This is 6W, I believe. And then U was 0U, right? In terms of its coordinates. Yeah. And then there's always that V in there, which is 2, 4. And that's going to help us with calculations. Okay, so let's figure this out. TA is going to be, oh boy. Well, we're going to have to label some things here. That point needs to be labeled right there. And I'm going to label that F, and then the Y coordinate is 12. So that's F12. And then this point right here, that also has to be labeled right there. So I'm going to call that E, and because it's on the x-axis, it's E0. Okay, so TA, let's see, 1/2. Let's see here. It's a trapezoid, right? So I can just use the trapezoid formula, which is this plus that. So that's going to be E plus F over 2 times the base, which is 12, right? Yeah. So that really is 6 times E plus F. Okay. And then TB, well, it's just 72 minus that, 72 minus TA. So we'll come to that a little bit later. And then we're going to need a relationship between F and E, so that's where the slopes come in. So the slope of, EV is going to be the same as the slope of FV, right? Okay. All right, so that's going to be 4 minus, let's do this carefully, 4 minus 0 over 2 minus E, and that's the same as 12 minus 4 over F minus 2. So 4 over 2 minus E is equal to 8 over F minus 2. So 16 minus 8e is equal to 4f minus 8, right? Okay, so if this is 24 minus 8e is equal to 4f, and therefore f is equal to 6 minus 2e. Okay, that's very helpful. So keep that for now. And then let's go back to these guys here. And let's see what happens. Okay, so if we go back to that, what am I going to do here first? All right. I think we can just compare them according to the ratio that they told us, right? And that ratio was 5 to 3, if you guys remember. So if the ratio is 5 to 3, we can just put that over there. So it's TA over TB. I actually don't know if it's TA over TB or TB over TA, but let's just do this one first, 5 over 3. And that's going to be, so TA is your 6E plus F. And then your TB is, 72 minus that. So 72 minus 6E plus F. Got it? Yeah. I think this is right. Yeah. Okay, so when we do this, I'm just going to quickly do it. You can solve for this, and then what you'll do is you will substitute this guy here, and then eventually you get one variable. When you do that, you'll get E equal to negative 1.5. Now that means that this doesn't give you any solutions, because as you can clearly see from the diagram, E is greater than 0. So no problem. What you do is you do the reverse. You say, okay, maybe this ratio is 5 to 3, which is TB over TA. You see what I mean? So then you just do the reverse, or whatever, reciprocal, I guess. Yeah, and then again, you substitute in that guy and you solve. And when you solve for that, you get E equal to positive 1.5. So that works because E is indeed greater than 0. So this is the solution. Now, we're not really interested in E. We want U and W. Okay, no problem. And that's where the slopes come in. So again, you use the slopes. So let's see here. It would be 0 minus U over E minus 0 is equal to 4 minus 0 over 2 minus E. And when you solve for this, you get, well, we got to plug in E equals 1.5. And when you solve for this, you would get U equal to minus 12. And when you substitute, when you again use this line to get the slope and it being equal, you would solve to get W equal to 36. So the solution would be U 0 minus 12 and W 636. And that's another solution to this question. If 5 over x plus 14 over y is 2 and x is 6, what is y? All right, so we have 5 over x and 14 over y, and that's equal to 2. And x, they already gave us that x is 6, okay, so that makes it easy. 14 over y is equal to 2, okay. So I guess we're just using common denominators, 6, y, and y. So that's going to be 5y plus 6 times 14, which I believe is 84, and that's all over 6y is 2. Okay, so cross multiplying, get 5y plus 84 is equal to 12y, and therefore 84 is equal to 7y, and therefore y is equal to 12. Determine all possible ordered pairs of integers x, y, so that 4 over x plus 5 over y is equal to 1. 4 over x plus 5 over y is equal to 1. So there's a long way, and then there's a more shorter way. The long way is easy, but it takes a long time. The shorter way involves a little bit of fancy algebra, but it's a little bit neater. So let's do it that way. So first, let's get the common denominator stuff going. So we have 4y plus 5x is equal to xy. Let's put everything on one side. So when we do, we get xy minus 5x minus 4y is equal to 0. So factor out an x, y minus 5 minus 4y is equal to 0. Okay, so this is where the fancy algebra comes in. We got to add 20 to both sides. So add 20 here, add 20 here. When you do that, let's rearrange this a little bit. So x, y minus 5 minus 4y plus 20, and this just becomes 20. Now you can factor this, y minus 5, and this becomes, let's see here, minus 4y minus 5. And then finally you can factor the y minus 5, and you get x minus 4. So as you can see with that fancy algebra, you get a very nice end result that you have two factors that multiplied together are equal to 20. Correct? Yeah. So then let's make a little table. So we have y minus 5, we have x minus 4, then we have x and y. So what are the possibilities? Well, two numbers that multiply to 20. So it could be 1 and 20. It could be 20 and 1. It could be 2 and 10. It could be 10 and 2. It could be 4 and 5. It could be 5 and 4. And remember, they're positive, right? They're positive integers. I think that's it. And then you solve for this. So if y minus 5 is 1, that means y is... hold on. If y minus 5 is 1, that means... Oh, sorry. That would mean that y is equal to 6. And if x minus 4 is 20, then x is 24. And similarly, they fill these in. If y minus 5 is 20, then y is 25. And if x minus 4 is 1, then x is 5. 25. And then if y minus 5 is 2, that means y is 7. And this, I believe, would be 14. This will be 15. And this would be 6. And then this would be 9. And this would be 9. And this would be, if y minus 5 is 5, then y is 10. And then this would be 8, I believe. So there we go. Those are the solutions to part B. And the final part, consider the equation 16 over x plus 25 over y is p. P is a prime greater than or equal to 5. Determine all possible values of p, for which there's at least one ordered pair of positive integers, x, y. That is a solution to the equation. All right. So 16 over x plus 25 over y is p. So first of all, p is greater than or equal to 5. So 5, 7, and so on, right? All those primes. But the good news is that since x and y are both positive, that means that this 16 over x is going to be greater than or equal to 16. Sorry. I should have said the opposite. Less than or equal to 16. Correct? And then similarly, the 25 over y, since y is positive, it's going to be less than or equal to 25. So this whole thing, if you add it up, is going to be less than or equal to the addition, which is 41. So p's got to be less than or equal to 41. So we're going to just use the primes going up to 41, which is obviously a finite list, and that makes our life easier. So I think there's only 11 of them, right? Yeah, okay. So P is one of these guys, but we're not sure. We have to figure this out. But this is our candidate list. Okay, so let's take this original equation and let's try to simplify it as much as we can. So that original equation is 16 over x plus 25 over y is P, right? Okay, so let's do this here. Y, x, x. So that's going to be 16y plus 25x, and the cross multiply and you get pxy. And then let's put it all on one side. Pxy minus 25x minus 16y is equal to 0. Okay, so perhaps this is also some fancy algebra. You got to multiply everything by p on both sides. And when you do, you get p squared xy minus 25 px minus 16 py, and that becomes 0. That remains 0, I should say. And then now you can factor out a px, and that becomes py minus 25, and this becomes minus 16 py is equal to 0. A little bit more fancy algebra. You got to add a 400 to both sides. So plus 400 over here. And when you do that, you can factor this now. So let's write this out a bit differently. Let's just rearrange it a little bit differently and make it look a little bit obvious. So plus 400 there, and then 400 there. All right. So now we can factor this out. Px times py minus 25, right? And then let's factor out a minus 16, and then we get py minus 25. So as you can see, that factors out very nicely. And then this becomes py minus 25 times px minus 16 is equal to 400. So when you do that, it becomes a very nice equation, and very similar to what we did before. So now we make a little table. We got py minus 25, px minus 16, and then we'll figure out px and py. And then we also have to figure out the common prime factor. So common prime factor of px and py. Okay, so let's do a couple, and then hopefully you'll get the hang of it, and then you can do the rest. Okay, so here we go. So remember, this guy plus the times that guy's got to equal 400. So let's do the first one. The obvious one, most obvious, is 1 and 400, let's say. So if py minus 25 is 1, that means py is equal to 20... py minus 25 is 400. Py minus 25 is 1, so py is equal to 26, right? And then px minus 16 is, so this is 416. So that one doesn't give us any prime. There's no common prime factor, unfortunately. Okay, so that's a dud. So let's try the 401, that guy. So if py minus 25, that means py is 425, and then px would be 17. Okay, I think this is going to work because 425 is 17 times 25. So that means the common prime factor is 17. See what I mean? Okay, I'll do one more. One more that actually works. If we have py minus 25 is 100, and this is 4. This is going to be 20. This is going to be 125. And 20, as you know, is 5 times 4. And 125 is 5 times 25. So the common prime factor there is 5. And similarly, you just keep doing this. And there you go. There's the master list of the entire calculation. And it's a bit time consuming, right? You got to do all these guys. But then the values that you get are here. And those are the prime numbers. And all of them, as you can see, are within our limit. And those are the ones that give you values of p that satisfy the conditions of the question.